So guys, are we live now? Let me check the voice. Let me check. Am I audible? Hello, hello. Am I audible? Let me check. Okay, we are live and voice is proper, I think. I think the voice is proper now. Okay, let me just check once. Let me just check one thing and then we'll start. Okay, so let me switch. Okay, so let's start. So what we were solving trees problems. Okay, let me just open it. We were solving binary trees, and I think we were in frequently asked questions, and we did vertical order traversal. Yeah, vertical traversal was done. So today we will be solving top view of binary tree. Oh, I think it is here. So let me just check. Let's do top view. It's not here. It's not in lead code. Actually, it's from GFG. So we will solve here only. I think the screen. Yeah, the screen is visible and the question is visible. Yep. Okay. All right. Let's go then. Okay, the question is given here, and we have to like solve this question. Top view of binary tree. So we root will be given, and we have to return the top view of the binary tree. So top view of binary tree is the set of nodes visible when the tree is viewed from the top, and we have to return from the like leftmost nodes to rightmost node, and if two nodes are outside the shadow of the tree and are at same position, then consider the left ones only, leftmost. Okay. So yeah, let's just a second. Okay, we will start from the scratch, and we will code from the scratch. We will first dry run it and then code it. Yeah. So here is the tree. True. Oh no. So this is the tree. So this question is basically based on what we have previously done. So this pattern is quite like identifiable. So this, like these are the columns, and these are the columns, and we are just including those elements which are like inserted at first, and like it will be like consider it 0, then on moving left it will be -1, -2, 1, 2. Okay. So decoding the pattern, we can have just like rows and column. We can have the column number. Yeah. So we can solve it using the level order traversal, and like we will maintain two things. First is the address of the node, and its column number. And if the column does not have any element, then we will insert it, and if already any element is there, we will not insert it. So like it's a queue. So this is a queue, and at first we will have this one. So this is the like node number, and this will be the like the level. Okay, so on coming to this, I will check if it has left. When it will be processed first, I will extract it, and then I will check if the if that is empty, like if the vector or yeah, what to say, like if it exists like this key, if the key exists, if key exists, then it means that already that element has been uh, placed, like that node has been processed, or that first node on that column is processed, so no need to insert into that key. Otherwise, if the key is not found, then definitely we have to add. So on taking this, and let's take it as a map. So this is a map, and it's also empty. So this is queue, and this is map, and this is node comma column, right? This is node comma column. So at first, when we are at here, we have checked if one exists, so one does not exist, so we put it here, and that, yes. So this is the node, and this is the, sorry, my mistake. Okay, that reverse column and node, right? Column and node, so that column will be 0 0. This is column number, what I'm doing, 0 marked 1, and processed it if do it has left pointer, yes, 2 left. On moving left, we will like, and then 3 1. So this is popped out. Now 2 2. Now we are processing 2. So 2, now we took this column number. Do minus 1 exist? No. So we insert it, minus 1 2. Okay, and left one is like what, -2. Arey yaar, what I'm doing. So left one is 4, and it's -2. What is this? Okay, and then right one, it's 5 and 0. So this second node is processed. Now we will move to third one. So third, so we will search, do one column 1 exist in the map? No. So we insert it, and we moved here, so we'll check it's right. sorry, left. So it's 6, and its column number will be like 1, then it will be 2, and on checking the right will be 3. So third thing, it's processed now. Now we take that fourth node and its column number is -2. So we check, do -2 exist here in the map? So no. Then we insert it into the map, and we are at 4. Do it contains any left child? No. Do it contains any right child? No. So so 4 does not contain anything. So we just removed it from queue, and then we come to 5. So we came to 5. We came to 5. Then we check, do 0 exist in the map? Yes, 0 exist. It means we need not to insert in that level, sorry, in that column, because we have to just look from the top, and the first, like the first element or the first node in that column which appears from the top, we have to keep that, and rest we have to omit it. So that 5, it will not be processed, it will be just discarded, because we don't need actually. We will like, yeah, we will not put into the map, but we will just look for its left or right, because who knows if something like this happens. So this will be visible, and we need to take care of this node. So we need not to put into the map, but we need to put into the queue. So this 5 is processed now. We will process 6. So we are checking. It will be 0 actually. Yeah, that mistake. On moving left, I would have to subtracted it, but I did something. Okay. So 6. It's a 0. So do 0 exist in the map? Yes. So no need to put into the map, and its left child and right child is null. So no need to like put into the queue. So it's processed now. Now we have gone for 7. So its column number is 3. So do 3 exist? No, it does not exist. Not 3, actually 2. It's 2. So do 2 exist? Nope. Yeah. So we put it here, and it's 7. And no left or right child exists, so nothing. So this map will keep these keys in the sorted order. So we will be having like this: -1, sorry, -2 will come first, -2, minus, yeah, what is this? This pen actually causing problem. -2, -1, 0, 1, 2. -2, it's 4, -1, it's 2, then 0, it's 1, then 1, it's 3, and 2, it's 7. So we have got this. So our answer will be 4, 4, 2, 1, 3, 7, है ना? So here in the output we are getting 42137. Yeah, right. So we have got this, and we have successfully dry run it. Now let's move to code. Like, let's move to that coding part. So yeah, let's move to coding part. One second, guys. We will move to that coding part. Just a second. Okay, so let's dive into the coding part. Um, yeah. So, what do we need? Actually, we need a map and we need a queue. So first, let's construct this map. Map we node star comma int. So this first will sorry. That's another thing. Map will be having int comma int, and we will name it mpp. Then we will have this queue, and yeah, the queue will contain two things: that node and its column number. So that will be of integer and name it queue. So let's push the push root comma 0, because that 0 will be 0 will be the root node, that will be the base node. So let's move it. Yeah, now do we need anything else? No, we just needed two things and it's done. So let's write the level order traversal while not q.empty empty size equals to q.size. So we get this size, and we have to like iterate for whole level. Eh, bro अरे भाई नहीं पता भाई, आउट ऑफ सिलेबस पूछ रहे हो? इट्स आउट ऑफ सिलेबस ब्रो. int I equals to 0, I less than size I plus plus. Okay, so we will process each node. So auto node, not auto node, like we know the data type, right? Auto node equals to q dot front. Oh, okay, q dot front dot first, or int column is equal to q dot front dot second. So we have got the tree and this thing. So yeah, if mpp dot find column equals to mpp dot end, what we do, let me just comment it out. If a node is checking if node is already inserted, checking if node is already inserted that column, right? So if it is not inserted, then mpp call equals to node value. I think it's data here. It's data node data. We have put it. If node q dot push. Okay, I need to pop it as well. Q dot pop it. Then q dot push. If left exists, then node left comma column -1. If node right q dot push node right comma +1. So if left node exists, then we will push that left node and that column value will be negative, like -1. And if node root right exists, then it will be node right and column will be +1. So this is the thing. So what we are doing, okay, got it. So this Q part is done. Now we need to extract that element, and what we have to return, like, yes, we have to return vector. So print answer for so it mpp. So it's dictionary. I hope I have that remembered that syntax. Let me just check. So that key and value pairs from dictionary in cpp. Every time I get confused, like I have to iterate. So how we iterate const auto question pair dictionary. First will be a auto question pair. Yeah, okay, mpp dot first and mpp dot second, right? So I need to just take so answer dot push back mpp dot second. Am I right? Return answer. Let's check. Let me just check this syntactical error. Happen teacher. Okay, and q pair. Hey, yeah, I got this thing. Remove int q push q root. Just a second. So yeah, it's this thing, and q dot size equals to 0. Node in column q dot front dot second. Okay, if already inserted. If it's inserted, we need not to do anything. I think it's fine. No, there are tons of errors. What is this? In the first line only, UE, pair, where, node, int, q dot push, root comma 0. What is this, yaar? Why it's giving me error every time? Map, end comma end. What is this? MPP call equals to node data. But let me just check. It's not here. Here dot second. So this is the one mistake I got. Still there will be mistakes, I know. Why this mistake is at first line only. Retain top view tree node star root. This thing. Not getting why this. But it's giving me push const value x. What is this? Why I'm getting this error? Q, it contains only one element as input. So this thing, why this? Here dot push map column node data. I why this? If let me just go to GPT because I'm not able to figure it out why this thing is happening. Is it that I missed that star? Was it the only mistake? MHC. Yeah. Why every time null check? This here also is that star like thing. That pointer. I need to store pointer here. That was just a blunder. It's in tactical blunder. Now I think all test cases should pass. Okay, let's run it. Okay, boom. This is done now. That top view is done. So now we are having what? We have done the top view. Now we have to do that bottom view. Now it's time for the bottom view of binary tree. I think this is also not on leetcode. The GFG problem. Find bottom left tree value. Okay, it's different thing. Yeah, this bottom view. Yeah, this thing is gone. What? Just in guys. Good. So we got here that bottom view. Okay, let's do this bottom view. Gets charged now. $20. That's 8, and it's 22. Then it's 5. Then it's 3. Then it's 10. Then it's 14. It's 25. This is the tree. $14. Just fall under is 22. Okay, let me just do it right. It's 14. This is 0. This is -1. Yeah, what is this? Yeah. This is 0. This is -1. This is 1. -2. 0. -1. It will be 1. It will be 2. So what we are seeing here at the bottom, so how we are doing it, I think because I have just solved this previous version, that top view, I have got an idea that I should use that recursion in a different way. Like when I'm moving, like when I am moving down, I'm not processing as I go to node. I am processing when will it work then. Okay, let's see. When I am processing when it's a leaf node actually. Is it done right? No. That leaf node. Let me just check one answer. 5, 10, 14 and 25. So basically I didn't have anything from the root node. Like I have just one question, like confusion over here. If this whole subtree, if this whole subtree is not here, like I have just removed it. If that whole subtree is not here, then what will be the answer? Will it be like 5, 8, 20, 22 and 25? I need to just get into this thing. Um, how can I do this? So 3 is included in the answer. No, 3 is not included here. Why? This is the outermost node. This is the outermost node. And like this is the outermost node. Is this is this node. This is also a root node. This is also a root node. Sorry, not root node, leaf node. Let me just check this again. 40, 20, 60 and 30. Okay, then according to this, we'll have 5, 10. Okay. At 4, I have got it. 5, 10, 14, 5, 10, 4, 14, and 22 and 25. Not 22, 25. Okay, I got a pattern here. Like in every column, the last element inserted, that is being like put into the answer. So the one thing which comes into my mind is that everything is like same, but what? Like I just need to get the last element. So let me just do it using that array. Like key will be the column and its value will be that array of all these elements, because after that I will just get the last element. Get into the coding part first. It's that space complexity will be, yeah, space complexity will be there for sure. I will be using q and q. Q pair 3 nodes star com and q push the comma 0. We will be having map and comma mpp. Sorry, we will be having a different thing here. Map and vector. So let's get into this while loop. While q dot ema and size equals to q dot size and I less than size I plus plus. Check my voice. Let's extract the node star. Let's extract that node star is equal to q dot front dot first and column is equal to q dot front dot second. Q dot we have just it. Now we don't need, there is no need of checking, we just have to put into the answer. Mpp call is equal mpp column dot push back e column dot push back node data The thing, if node left exists, q dot, since we are moving left side, we will do it minus. Right exists, we will do q dot push node right to column plus. This is the thing, and then we will iterate to the map for auto ampersand it. So we are doing this thing, then we will go. Okay, we need to get that last element of that vector. So yep, we will do this. Int size will be it dot size dot second dot size, and then we will, okay, we have just forget to like initialize that answer vector. Okay, that code was not visible. Okay, no problem. I just forget to just switch that profile. Okay, let's do answer dot push back it dot second size -1. Hope it's going to work. Then return answer. We just check it auto id mpp, then we got this thing. Second will be the vector. Yeah, I hope it works. Okay, it's worked fine. Okay, since it worked fine, no need to check. So let's submit this. Okay, this is also done. Okay, this bottom view is also done and dusted. But yeah, I think I have just used more space to what can I do? Like, how can I that preserve that space? Because I am unnecessarily storing all those elements, all the like the vector. I just need that last element. So how do I check if it's last element or not? Hmm, how do I ensure? Let me just go through this editorial. Remind the bottom we need to capture the nodes that are from the below this and every node that appear at lowest vertical order for it. By tracking the horizontal distance of each node from. Yeah, this thing I have already done. Set up a queue to facilitate breadth first search. Yeah, I'm doing this breadth first search. This thing. So, is there any way of like avoiding those vectors, storing those vectors, which like that I have done in that previous question? Like I was just storing single element, which was the only required element. Uh, yeah, there is a way of reducing the space complexity. Oh, oh, nice. Hello, buddy. Hello, Shikhar, bro. What are you solving now? What are you like? Which concept you are revising, Shikhar, bro? Like, what are you doing in DSA? I want to just ask this thing.